Hi folks, we're going to take a look at an example of graphing a non-sinusoidal trigonometric function. Okay, so this is a function we're going to graph. It's a cosecant function. Okay, and before I even start talking about any of the trigonometry here, of course my first step is just going to be to factor this input so I can interpret the transformations correctly. So I'll factor out the 1/2. Okay, so here we're left with pi over 6. Okay, not a bad idea to always check. 1/2 times pi over 6 is indeed pi over 12 plus 1. Okay, so we have a whole bunch of transformations here, but let's just take a look at what exactly we're going to be transforming. So the cosecant function. Let's just say for whatever reason you're just not remembering exactly what the cosecant function looks like. Remember that it's the reciprocal of the sine function. Okay, so here our vertical asymptotes are going to occur at pi, at 2 pi, of course at 0, and our function is going to look like this. Okay, so let's just draw one cycle of the graph. Okay, so what this helps us determine is where the original asymptotes are and the special points that we're going to use, and I think it makes sense to use pi over 2 and 1 and 3 pi over 2 and -1. So those are the special points that I'm going to use. They're the only ones I'm going to use. That'll be enough to draw a decent graph. Okay, so first thing I'm going to do is I'm going to figure out where the asymptotes are going to be. Okay, so let's take a look at what's going to affect the asymptotes, and that's going to be the horizontal transformations. So here I see this multiple of 1/2. That means I'm going to have a stretch by a factor of 2. Okay, so that's going to mean that my asymptotes are going to be, instead of at 0, pi, and 2 pi, everything's going to get stretched out horizontally. So I'll have asymptotes at pi, 0, 2 pi, and 4 pi. Okay. Notice here how I need 3 asymptotes because I want to be able to draw at least one full cycle of this graph. Okay, but the other thing that's affecting the asymptotes, okay, so not a bad idea to, especially since it's not a graph we do very often, to kind of use this as a guide to go through it. And of course everything's going to be moved to the right by pi over 6. So we're going to be moving those asymptotes to the right by pi over 6. Okay. So now let's transform a couple of special points. Okay, so we said one that we're going to take is going to be pi over 2 and 1, and the other point that we'll take is 3 pi over 2, okay, and -1. Okay, and let's transform these points. Okay, so let's see what's happening to the x values. So here, remember, opposite operations. So we're going to be, instead of dividing x by 2, we're going to be multiplying the x value by 2. Okay, and then adding pi over 6. Okay, and then for the y values, nice and easy, we're multiplying the y value by -2. Okay, and then we're adding 1. Okay, so this point here is going to get transformed too. So this is just going to be pi plus pi over 6. So 6 pi over 6 plus 1 pi over 6 is going to be 7 pi over 6. So again, see how I'm using that trick of working with a common denominator. And here -2 plus 1 is -1. Okay, there's my first point, and my second point here. So 2 times 3 pi over 2 plus pi over 6. So you see how I'm just using the exact same methodology for transforming this function as I would have, say, any other. So here we got -2 times -1 plus 1. Okay, and so here we've got, this is going to be 3 pi plus pi over 6. So 3 pi is like 18 pi over 6 plus 1 pi over 6. So it's going to be 19 pi over 6. Okay, and our y value is going to be 2 plus 1 is 3. Okay, so here we have our points. We know where our asymptotes are going to be, so they're going to be at pi over 6, 2 pi plus pi over 6, 4 pi plus 5 over 6. So now let's set up our graph. Okay, so here I'm just going to move this around so that, okay, we can set up the graph. So in terms of the y values, nothing too complicated. We need to be a little more on the positive side than on the negative side. Okay, so I'm going to move my x-axis down. Okay, and since I'm moving to the right, I'm just going to keep my y-axis In fact, I can even keep it right on the edge here. Okay, so let's put down our axes here. So there's our y-axis, and our x-axis. We'll bring it a bit further below the there we go. Okay, so for our y's, we can just go up by 1. So 1, 2, 3, and here -1. That's what we'll need. Okay. Now, remember here, I've got to go up to just over 4 pi. Okay, so I've got quite a bit of room, so I can even, make this 2 pi. Okay, split it up into 4, and then 1, 2, 3, 4, 4 pi, and I still have enough room to go to the right by pi over 6. Okay, so now let's draw our asymptotes. Remember, you want to set up your structure first before you start plotting points. So this is pi. Okay, so this is pi over 2. So pi over 6 will be about 1/3 of that. So it'll probably be about 1.5 of these really small lines. Okay, so there's one. Okay, and again, please do this with a ruler. Makes life a lot easier. And now once I know the distance from those nice numbers, it's easy to draw the asymptotes. Okay, so there's our last one. Okay, now we can draw our points. Okay, so here we have 7 pi over 6, -1. So again, this is going to be pi. 7 pi over 6 will just be pi over 6 over here. So, and what do we have? Sorry, it's -1. Okay, so 7 pi over 6, -1. So there's our point. Okay, and here we know that this is going to approach the asymptote on either side. So our graph is going to look something like this. So as long as it's reasonable, that's okay. Okay, then on the other side, we're going to have, well, we have 19 pi over 6. So remember, that was 3 pi plus pi over 6, and that's going to be at +3. So there's our other point, and now we know that this is again going to approach the asymptote. Okay. And again, I suppose on this side here, you can sort of, draw the graph. It's going to go there, and there's not really much room to draw the graph on this side. I suppose if you wanted to, you could just draw that there, because it's going to bring up to +infinity. Okay, and that's what our graph looks like. So just to recap. So number 1 is make sure you know what the parent function looks like. In particular, you need to figure out where your special points are and where your asymptotes are. Okay. From there, what I did first is figured out how my asymptotes are going to change. And of course, that's going to involve using the horizontal transformations. And then I picked my 2 nice points, which was one local minimum, one local maximum, and transform those points. And then once I have all this information, I can choose my scale very carefully, and then plot my points, plot my asymptotes, graph my function. Okay, so that's it for this one.